Hi, good morning. In the previous PPT, we discussed about the types of reinforcement matrix and detailed description. In this PPT, we are going to discuss about the what are the factors affecting the properties of the composites, and next we will see about the what is the difference between the composites and the smart materials, and finally will be the conclusion. uh, First, what are the factors affecting the properties of composites are the type, distribution, size, shape, orientation, arrangement of the reinforced will affect the properties of the composite materials and its anisotropy. And the corresponding shows the distribution, concentration, orientation, shape, and the size. These are the factors which we really influence the properties of the composites, especially the strength of the composites. Based on these factors, the strength can be varied. Uh, Advantages of the composites are light in weight and low density, high creep resistance, strength to weight and stiffness to weight were greater than the steel or aluminum. Fatigue properties are better than the common engineering metals. Composites can be corrode like steel. Ease of fabrication of large complex structural shapes of modulus or modular construction. Ability to incorporate sensors in the material to monitor and correct its performance. Smart composites. Higher resistance to impact damage, improved corrosion resistance. Next, high cost of raw materials and fabrication. Composites are the limit. Next, we will see the limitations of the composites. The limitations are high cost of raw materials and fabrications. Composites are more brittle than the wrought metals and thus are more easily damaged. Transverse properties may be weak. Matrix is weak, therefore low toughness. Reuse and disposal may be difficult. Difficult to attach. Difficulty with analysis. Cost can fluctuate. Next, you will see the difference between the smart and composite materials. Smart materials have multiple functions, which generally include sensor actuated ability in addition to having form or being able to support at least one some structural weight. The classic example is entinol, which is nickel titanium alloy. After mechanical deformation, it can be heated up and will be returned to the pre-deformed structural cells. Composites are materials that are combinations of at least two materials which allow the engineering of the design materials like delivering the mechanical stiffness and rigidity. Classic examples are glass fiber composites. Next, we'll see the civil engineering application of composite materials. Civil engineering composites are including small concrete. Small contrast under loading and unloading process will lose and regains continuity, thus serving as a structural material as well as sensor. Smart concrete plays a vital role in the construction of road pavements as a traffic sensing recorder. Next, rehabilitation of and retrofit. In the case of materials are usually bonded extremely to structure in the form of tows, fabrics, plates, jackets. The advantages offered by the composites in the form of include their ability to bond well to many substrate materials and to follow complex shapes. Other applications are advanced composite materials for highway bridges. Mm, the next will be the road bridges. Next, FRP door and door frames. Next application will be the train made up of FRP composites. The composite materials are increasingly being used in the railway industry, weight saving up to 50% for structural and 70% for the non-stop rails, bringing associated benefits of high speed, reduced power consumption, lower interior, less track wear, and able to carry greater payloads. Now, more and more parts are made up of GFRP, which includes resist corrosions and has extensive workability. Mm, next you will see the failure modes of the composite materials. The failure modes of composite: delamination, matrix tensile failure, matrix compression failure, fiber tensile failure, fiber compression failure. Next, coming to conclusion, several innovative FRP systems can present as showing the different advantages that each of them can provide to designers, contractors involved in these types of upgrades. The potential future benefits of the smart materials, structures, and systems would prove amazing in their scope. A smart structure can have the capacity to respond to the changing entire environment, such as loads, temperatures, shape change, as well as to varying internal environment. Thank you.